Hey guys, today we're going to be looking at simplifying radicals, and we wanted to kind of talk through the process, the different parts that you might be seeing as we simplify radicals. This is something that we'll be using kind of from here on out for the rest of the year, dealing with Pythagorean theorem and possibly even with our quadratic formula getting exact values. So simplifying radicals is something you'll continue to see throughout your math in the future. Okay, so as we go through this, we've talked about we're going to use kind of that factor tree method. So as I go through this problem, you'll see this kind of branch out. We talked about it also being kind of like roots for our tree. But regardless, you're going to see kind of a form where it kind of branches out as we go. The key thing is factors. Factors, again, are numbers that multiply together to get whatever value we're talking about. So right now, if I'm looking at 27, we're thinking of the factors, or I'll say, what's the factors of 27? We're thinking of two numbers that multiply to get me 27. Okay? If I have a number out front, I essentially am going to take this number and it is going to come down all the way down to the answer, or at least to right before the answer. Okay? I don't need to do anything with the factor tree with this right now. This number would just come down essentially to the end. Then I'm going to get into my factor tree. Okay? So if there's a number out front, right away I usually draw this arrow to remind myself, hey, this number will be there at the very end, okay? Our 27, okay? When I deal with my radicals, I'm going to create a factor tree. Each line is representing a number that is being multiplied times another number to get me that 27, okay? So the numbers at the bottom of each of these lines should equal, when I multiply them together, the number above 27. So if I think about numbers that get me to 27, our number would be 3 times 9. Our 3 here is as far as it can go. So we try to get our factors, we're trying to go as far down as we can possibly go. So our 3 here can't factor any further because there's nothing else besides 1 and 3. We will never use that 1 in itself, or 1 in that number. We'll never use that as a factor. So for this one, 3 is as far as I can go. Okay. On the right side here, I've got 9. So the factors of 9 are 3 and 3. And we just said 3 is as far as I can go, so I'd say here and here are where we'd stop. Okay. Once I've gotten to where I can't factor any further, I can't get any other numbers branched off from there, I'm going to look to circle my pairs. Okay. I'm choosing pairs right now because this is a square root and it doesn't have a different value in its index. So if they had like a 3 here, the cubed root, we would do this a little bit differently. We would be circling up sets of 3. Okay. Right now, and for this unit, we're only dealing with square roots, so I'm only looking for pairs of 2. Okay? So for this one, I can look and see, I can either circle these 3s, the opposite 3s. It doesn't really matter which pairs you're circling as long as you circle them up. So these two happen to be right next to each other, so I'm going to circle these and say this is my pair of 3s. Okay? We've talked about whatever is circled comes outside the radical. So these 3s right here are getting out of the radical and will be written out front. I don't have any other pairs, so I can go ahead and write my radical symbol. Whatever is left over, that is our factor at the bottom. So again, that's why I underline these to show which ones are kind of our factors at the bottom or what's left. So what's left here is this 3. That's all by itself. So the 3 all by itself goes inside my radical, so I'd have a 3 here. The big question is if I have more than one number, and right now I have more than one number out front, or if I have more than one number left over, we multiply those numbers together. So here I have 2 times 3, so my answer would be 6 square root of 3. Again, this 2 comes from the very beginning. Okay? So this would be my simplified version of 2 square root of 27. Okay? Again, factor tree listing your factors out. Number, if it is out front, comes all the way down. Okay. I had some students ask me, Mr. Schultz, what happens if there's nothing left over? So if this 3 wasn't here, then I would be done at 2 times 3 and it'd just be 6. Okay. That is okay. That's one that actually would be a complete factor, or would probably be a perfect square. Okay. So if I look over the other one on this side, same kind of deal, except for now I'm adding in a couple variables. So our process doesn't change. We essentially are dealing with this as kind of 3 parts because we have 3 different pieces here. I have a number, square root of 12, so square root of 12, I'm going to write and get ready to factor over here. The square root of n squared n squared tells me I have two n's, so I can write this out as n times n. P to the fifth, I have 5 p's, so it's the same as p times p times p times p times p. I've talked about also writing kind of in a stacked method. This is more commonly what I've used. So this is something that you can kind of use here. If you'd like to see the stacked method again, you can ask us, and we'd be happy to kind of go through that and show you that again. Okay. So as far as my number, we're going to do the exact same process as we did over here with the 27. Some students get concerned. They're like, well, which pair does it? Which pair do I need to pick? I know there's more than one factors of 12. I could do 2 and 6 or 3 and 4. It doesn't make a difference because at the end you'll end up with these same factors or roots out of this thing. Okay. So let's just say we're going to pick 4 and 3. Okay, so I pick 4 and 3. 4 and 3 are my two initial factors here. Okay, the 4 can continue to factor because we know 2 times 2 gets me to 4. The 2's can't go any further, so I would again underline, circle, highlight. When we're doing this in class kick, I would for sure use that highlighter to mark those to let us know we're done at that point. Over here, the 3 does not factor any further, so I'm going to underline that 3. We then look for our pairs. So as I look at this problem, I have a pair of 2's right here. I don't have anything else with a 3, so that tells me at this point I'm as far as I can go. There's nothing left to factor. I've circled all my pairs. So whatever is circled comes down as part of my answer. So I have a whole number 2. Whatever is left over, so my leftover here is a 3, goes inside my radical. Okay. So I've got 2 square root of 3. Over on the right side with my variables. The variables, again, we are looking for pairs. So I will circle up pairs. So I have one pair of n's. Because I only have one pair, only one n is coming out. So for this one, and I think, yep, you can still see that, we've got an n. So that's a whole number n that's coming out of this problem. For our p's, again, I'm circling up pairs. So I have one pair here, another pair here, and I have a leftover. Okay, so what this is going to get me, or what I would write this out as, is I have 2 p's, which is like p times p, which gets me p squared. The leftover stays inside the radical. Okay. Again, another way to think of it is however many circles with our variables we have is the exponent you're going to put above that variable. Whatever's left over again stays inside. I need to get to my final answer. My final answer is kind of combining things together. So whatever is outside of my radical is going to go in front of my radical here, my answer. So from the numbers, and we'll always start with the numbers, our number here was 2 on the outside of the radical, so I have 2. The n's, I have one n, it's not in the radical, so I can put that out front. I have a p squared. Again, not inside the radical, so I'm taking care of everything outside of the radical. Now when we go inside the radical, for my answer, I have a 3 for my whole number. There was no n's inside the radical here, so I don't need an n to hold the place inside my radical. For the p, I have a p left inside the radical, so that is going to come inside of my radical, and that would be my final solution. Okay. Again, this is kind of walking you through those steps. Let us know if you've got any questions on simplifying radicals. Make your factor tree, circle your pairs. Inside the circle, comes out of the radical. Whatever's left over stays in. All right. Let us know if you got questions. Otherwise, I'll see you guys soon.